If you've successfully loaded the Spark Notebook system and have viewed the previous video on writing Scala using Spark Notebooks, then you're ready to start exploring the tribute payment data that we're going to look at in this assignment. The first thing we need to learn how to do is how to download a URL, extract data from a URL reference in Spark Notebooks. And I'm going to do that by first simply identifying the URL. You'll see it looks familiar if you've bookmarked your course homepage. The file in our course home directory is called forosdata.csv. Foros is the Greek word for tribute. And I'm going to use the val keyword you've seen before to define a string value called foros URL. Now the core Scala library, the core Scala language, doesn't have any objects or methods for no functions that will read URLs, but there is a library called scala.io.source that does include that kind of functionality. So we're going to import that library first of all, and then we'll use a function in the scala.io.source object called fromURL, provide it with the URL we want to read, and that'll retrieve the contents. We can also then convert those contents to lines using a function called getLines. So let's take a look at a new empty Spark notebook and begin to explore that just a little bit. I've got an empty cell here. By default, it's a code cell, but I'm going to change it to be a markdown text cell because I want to make some notes to myself as I'm going along here. And I'll make that a heading in markdown, that little notation. I want to note that the first thing we want to do is download the tribute data in comma separated value format, and we want to turn that into a list. Okay, so that's what I'm going to try to do. Now let me append an empty cell and start working with my code in there. I'll copy and paste here just a little bit to save myself chances of making errors. You can see that all I've done is define a string object. You've done this or seen this done at least in previous videos. And then I want to be sure as well that I import the scala.io.source object so that I can use it to read that URL object. And let's see what happens if we just use scala.io.source with its fromURL function. And I can make sure I can execute this, and it will work good. It tells me that's a non-empty iterator, which doesn't mean much to me, but I can apply a function to turn that into a bunch of lines, and I want to save those lines as a list. So these are two successive functions I'm applying to the content that I read in with that fromURL function. And the result of that is that I've got, as the line here indicates, a list of strings. So every line of text in that CSV file is one item in a Scala list. I'm going to make use of this in my notebook, so let's save that and call it something like foros lines. And make sure that our code, I didn't enter any typos. I've got a nice clean block that does the first task. I've turned this reference in a URL into a list of strings in Scala. Now, Scala has a number of generic functions you can do to any kind of collection, like a list. There's several sorts of collections in Scala. But three of them we're going to be introduced to here that we want to make use of in exploring our tribute data. One is the filter function. This lets you define conditions to select, or if you will, search on conditions in a list. A second is named map. This name may be a little confusing. It's a mathematical term. What it does is transform each item in a list. So mathematically, it's a mapping of items in one list to items in a new list. But you can think of it as transforming a list, just as filter is selecting from a list. And the third one I want to mention is called group by. You can cluster items together in a subgroup. So if we wanted, for example, in this assignment, we're going to group together all the payment records by year. And we'll wind up with, we'll use the group by function to achieve this. And what we'll wind up with is another kind of structure, not a simple list, but what's called in programming terms a map structure. The organization of a map structure is a key pointing to some value. So we'll have a year number and then a list of payment records, maybe a very, very long list of all the payment records for a given year. So what we're going to try to accomplish in this assignment is we could outline something like this. First, we want to filter out any incomplete records. Don't forget that the stones these are recorded on are highly fragmentary. Not every record is completely preserved, and we don't want to try to analyze, at this point at least, records that don't have, for example, quantities paid for that recorded payment. So we'll filter out incomplete records, and then we're going to transform just this raw string data from the text file that we downloaded into payment objects. Recall in the previous video we saw how you can define your own class of objects. We'll define a payment class and transform string data into payment type objects. And then finally, we'll group them together by year, and that will create a map structure that will give us an index of a year, a key of a year, pointing to a list of payments. So let's first of all begin by filtering out our structure just a little bit and see what we can do. Now, one of the neat things in Spark Notebooks is that I can continue to work in a subsequent cell, and the objects I've created in the previous cells are available to me. So for us lines, for example, we created a list of strings. That's still here. That's still good. I can apply to a list a size function, the same way we saw using a size function on strings to count characters. Using a size function on a list tells me how many items in a list. So I've got 784 records here in this downloaded list. But what I want to do right now is put a filter function on that list. And what I want to test for is that I have a complete record. Now, let me see what a complete record might look like. One of the things you can do on a list is apply a function called head. And head simply extracts the first item in the list. So this comma-separated text has a header line, and it gives you the kind of labels for the columns separated by commas. So I can see that I have 1, 2, 3, 4, 5, 6, 7 items, 7 columns in my comma-separated text file. So what I'm going to filter on is making sure I'm going to select out only those records that include 7 columns. The syntax looks something like this. My test is going to be, is the size of each record equal to 7? If there are 7 items, I'm sorry, I've got to do first. That's what I want to find out ultimately. But I've just got right now simple lines of text. We want to break up these columns identified by commas. So first we're going to transform the text. Instead of one single line of text, we're going to produce a list of 7 items of text. And to do that, we're going to use the map function. But we don't want to include the head data that we saw here. Reminder, this is what's in the first line. Tail is the complement function. It gives us everything after the first line. So we're going to run a transformation on all the real data entries. And what we're going to do is convert each line, that's just one unbroken string, into a whole series of lines, a whole series of string values. And the syntax here says apply the transforming map function. Take each item in this list, let's call it line, and it's a string value, so I can use the string class's split method to split it up on commas. So we'll split each line into a list of strings, and that kind of list is called an array. So here I've changed a list of strings into a list of lists, if you will. And let's call that now something like records. So I'm getting down to something I can work with, and I'm going to now try to filter those records. And the condition I want to test on is the size of each list now equal to 7? If there's 7 items in the list, it's a complete record. If there are fewer than 7, it's not. So if I try something like that, I've got a new list, but it's only including entries where I've got 7 items listed. So I'm down to 707 from 780 some. So we've thrown out the ones that are incomplete in some way. So to make things clear, let me just call these full records. And let me insert a note here to show myself what I'm doing. I'm noting that we need to split up each line of text on commas and filter out any resulting lists that don't, well, let's go ahead and be precise here. Let's use the programmer's term. Any resulting arrays that don't have 7 items. Okay. And that's what we've done. Good. Now, what I want to do is convert those list of 7 items into a payment record. And so I'll remind you that in our previous video, we saw how it's possible to define your own classes. That's what I'm going to do here. Let me note that, well, let's just paste that in. I'm going to throw out the first couple of items. I should probably, before we do that, let's review records for us lines. Head. Let's just review what the comma-separated text looks like. I don't need the payment ID. I don't need the reference to the test passage for this work, but I do want to get the labeling text, the sequence, the year number, an identifier for the place, and the quantity paid. So I want to get 3, 4, 5, 6, 7 items out of each record. I want to model those in my case class. So here's a way we could do that. The label will be a string value. Sequence within the year is an integer. The year, remember, is just recorded as an integer count, an identifier for each place. And then the number of ovals are sometimes fractional. You might be paying half an oval, so I don't want an integer. I'll use a float for that. That's a floating point number that might be a fractional value. So let's make sure we can define a class payment. We've done that. That's ready to use. Good. So the next step is going to be transforming every raw string to a payment object. So remember that I've split up the strings into arrays of strings. So now we're going to transform each of those arrays into a single payment method. Let's go back to our notebook and continue our work here. What that means is we're going to work with the full records that we filtered out here only. We're not going to try to do anything with the records we ignored. We're going to, once again, use the map function to transform our list. In this case, each item in the list is an array. I'll just, for short, call it ARR. And what I'm going to transform that into is a payment object. And the payment object is going to be comprised of item 2, 3, 4, 5, and 6 in the list. If you're saying, wait a minute, I thought we wanted the 3rd through 7th items, we do in Scala, as in many programming languages. You count elements in an array beginning with 0. So ARR parentheses 0 would be the first item in the list. So this is the 3rd item in the list. That's our label. The 4th item, which is our sequence number. But notice that if I just read it in as text, it would just be another string value. I want to indicate, convert that string to an integer, convert the year reference to an integer. get the labeling string. That's just going to be a string value. You don't have to change it. And the last reference to the ovals, I want to convert to floating point fractional values. So when I now do this, I've created a list of payment objects. All right? So instead of simply a list of collections of text data, I've got my structured payment objects. And one of the neat things that Spark Notebooks will do is then give you graphic ways of exploring this, viewing this. Here we have a table view of your payments. You can sort on those different columns and so forth. Explore them in different ways, apply functions to do things like count them, do averages on them, and different kinds of manipulations of that structured data. Okay, so that's good progress. We've got these better organized. I certainly want to save that. Let me call this payments. And if I wanted to have that nice little set of automatically provided ways of viewing and sorting the material, here we are. That's not right. I made a mistake. We want to call that keyword val, not valley. It's not present, but all I have to do is make the last statement in my cell the object that this cell is sort of looking at, so to speak. And now I'll get payments, a view on payments as a table, a view on payments as this kind of slicing and dicing option. And good. So we've got our data well organized in payments. That's great. The next step is our assignment is to try to view this by year, view payments by year. And so this is where the Scala group by function will become very useful. Let's give ourselves a new cell. Maybe I should add here a note above that explains what we're doing. Define a payment class and transform every list of string data into a single payment object. Okay. Now I'm going to go ahead and make this a markdown. My goal is going to be to group payments by year. That's what I'm going to try to do in the next cell. This is going to be nice and easy since we've got things structured so well already. You'll recall above that when we did a filter, it didn't explain this notation. The underscore means when you're applying a function to every individual element of a collection, the underscore is a shorthand that just means each element individually. See up above, we filtered out the list of arrays to find only those where each individual array has a size function with a value of 7. We're going to do something very similar here. We're going to group each element in our payments list by each element's year member. So recall from the previous video when we were working with our own case class, our own defined class, that we could refer to member elements just by their name like this. So this is going to group every payment together, cluster them by the value of their year element. Let's test that. End result is now we have a map. It's a map of integers, because that's our year numbers are integers, to a list of payments. So we've clustered together every payment under its appropriate year. And so here now in our automatically provided viewer, we can see that we've got records for year 1, 2, 3, 4, 5. Remember that year 6 is missing from the tribute list, and year 7 and 8. And in each of those 7 years, we've then got a long, long list of payment records. So that's exactly where we want it to be at this point. The last thing we want to do is then sum together payments by year. So we're going to have to do that in 2 steps. We're going to have to transform now our map of year payment records to just the ovals in that, just the payment quantity in that record. So let me make a note to myself that what I want to do here in the last step is transform payment records to oval value, then sum up the number of ovals for each year. Let me add a code cell and see if we can get to work on that. I called, oh, I didn't save this. Let me make sure. We grouped them by year. Let's just call this by year. And now the mapping structure, that map structure, is available to me in my Spark notebook. And I'm going to map the contents of that. So let me say, to minimize the confusion, I'm going to use the map function to transform the contents of that map structure. And the syntax is just a little different when I'm working with a map structure instead of a straight list. It's going to use the case keyword to say, well, when you've got a structure that looks like a key and a value, here's the way I want you to map it. Map it onto exactly the same key. Sorry, there we go. But I'm going to turn this into something different. I have a list of payment structures for each year. I'm going to convert each of those lists to, in fact, change each payment record to just its ovals component. So this is a little subtle, but what it says is you have a map structure called by year, and you're going to transform it. And if it happens that your map structure is composed of a key and a value pair, the way you're going to transform it is into a new pair, but this time keeping the same key, our year number. Instead of a list of payment records, you're going to map each payment record onto just its oval value. You should wind up with years, then grouped by year, a whole bunch of ovals. So there we have a whole bunch of, a good example here, year 1 payments had the following amounts: 100, 100, 45, 100, 70, 200, et cetera, et cetera, et cetera. The wonderful thing now that we have this so nicely structured is a single line will let us turn this into not just a list of the oval values, but their total. We're going to apply a sum function to that list. And now what we've got is, for each year, the total number of ovals that were paid. And let's view it that way as a bar chart. Easier to understand. When we mouse over, we see the numeric quantity, the total for that year. So there's a brief introduction to ways we can begin to explore tribute data in our Spark notebooks. We'll do this more together in class. But this has just walked us through importing it from a CSV file, putting it into an appropriate structure, transforming the data structure so that we could organize total quantities by year, and viewing that in Spark notebooks as a bar chart.